Okay, 2018 AP Calc AB number 2. Nope, sorry, number 3. Given the graph of the function g, which is the derivative of f, so that means this is the graph of f prime, and g is a piecewise linear function, so that's telling us all those pieces are lines up until x equals 3, and then from 3 to 6, it's the parabola that has that equation. First question, f of 1 equals 3, what's the value of f of negative 5? Straightforward FTC question. If we integrate f prime of x from negative 5 to 1, that's going to equal f of 1 minus f of negative 5. We can get the value of that integral because that's just the area. And then we know f of 1, so our only unknown is f of negative 5. So our area, we have the trapezoid below the x-axis, negative 1/2 of 3, which is the height, times the sum of the bases, plus the 0, that just piece from negative 1 to 0 that's on the axis, and then plus the triangle from 0 to 1, 1/2 of 1 times 2. And that has to equal 3 minus f of negative 5. So we sum all that stuff up, it gives us negative 19 over 2 equals 3 minus f of negative 5. Move the 3 over, which is 6 over 2. So negative 19 over 2 minus 6 over 2 is negative 25 over 2 equals negative f of negative 5. So 25 over 2 equals f of negative 5. Part B, evaluating the integral from 1 to 6 of g of x. Okay, so we can split it up and go from 1 to 3, where it's just area, and 3 to 6, where we have to do the antiderivative. So 1 to 3, our area is, we have this 2 by 2 square plus the integral, the integral from 3 to 6 of 2 times x minus 4 squared dx. So we keep the 2, 1/3 from 1 over the new exponent, x minus 3 cubed from 3 to 6. So we sub in, we have 4 plus 2/3 times, subbing in 6, 6 minus 4 is 2 cubed, minus, sub in 3, 3 minus 4 is negative 1 cubed. So we get 4 plus 2/3 times 2 cubed is 8, minus negative 1 cubed is negative 1, so minus negative 1 becomes plus 9 cubed. So we have 4 plus 2/3 sorry, that's not a 9 cubed. 4 plus 2/3 times 9. That 3 is the bound from up here. I knew that was going to happen when I wrote it. 2/3 times 9 is 6. 4 plus 6 is 10. So again, it's 4 plus 2/3 times 8 minus negative 1, or 2/3 times 9. 2/3 times 9 is 6. 4 plus 6 is 10. Part C, when is the graph of f both increasing and concave up? And give reasons for your answer. So f is going to be increasing when f prime is positive. Where is f prime is positive? Well, where is this graph of f prime above the x-axis? From 0 to 4, and again, from 4 to 6. And concave up is when f prime is increasing, or when this graph of f has a positive slope. So where is f prime increasing, or where does it have a positive slope? From 0 to 1, and again, from 4 to 6. So where are both true? On what interval or intervals is f both increasing and concave up? Well, what do these have in common? From 0 to 1, forget about the rest of it to 4, but from 0 to 1, and again from 4 to 6, because f prime is greater than 0 and has a positive slope on those intervals. The last part, find the x-coordinate of each point of inflection of the graph of f and give a reason. The only point of inflection is at x equals 4, because it's the only place where the slope of f prime changes sign. Okay, negative to positive. Going from 0 to positive to 0 to positive to 0 doesn't count as a sign change. Okay, positive to negative is a sign change. So that's our only point of inflection.